In this study, researchers wanted to determine whether drivers are more distracted when they're using a cell phone than when they're just talking to a passenger. Due to the ethics of such a study, it makes sense that they're using a driving simulator instead of actually going out on the road, because if they were actually going to be putting people in harm, that just would not be ethical. That would not be a good way to run your studies, and most boards of review would never let that pass. So anyways, let's go ahead and look at part A. We have some numbers in here, we'll get back to those in a second. Would this be classified as an experiment or an observational study? Now, an experiment is where the researcher controls where people go, what groups they're assigned to, what treatments they get. In an observational study, you just watch what people naturally do. Here it says that people were randomly assigned to drive in one or the other. So the random assignment means that you are not dealing with an observational study, but an experiment. For B, state the null and alternative hypotheses of interest. We, in this problem, have a couple proportions that we're dealing with. So one of them is 7 out of 24, and that's referring to the cell phone users that missed their exit. And the other is 2 out of 24, and that's the drivers that had a passenger that missed their exit. So more people missed their exit when they were on the phone than when they were talking to the passenger, but we need to determine if that's actually significant. But again, getting back to this question here, all it asks for is a null and alternative hypothesis. So here, we're comparing two proportions. The null is that the proportions are always going to be equal. So I'm going to say proportion cell, P cell, is equal to P passenger, P pass. So the two proportions are equal. That's our null. Now the alternative hypothesis is that whether one's greater than the other or just that they're not equal. And it says in the first sentence, researchers want to determine whether drivers are significantly more distracted while driving with a cell phone. So the alternative is that P cell is greater than P passenger. That is, that the proportion of people who miss their exit on the cell phone is greater than the proportion that miss their exit just with the passenger. Part C, one test of significance would be a two-sample z-test, and in this case it's actually referring to two proportion z-tests. So the two-prop z-tests in your calculator. State the conditions required for this test to be appropriate, and then comment on whether each condition is met. So it doesn't say to run the test, just talk about the conditions. One, you can look at the experimental conditions, in that you have 48 people, and half of them are randomly assigned to one treatment, and the other half are randomly assigned to another. But otherwise, it seems like the passengers would be, or the drivers would be otherwise equivalent in each situation. So that seems like a very valid statistical design, valid experimental design. The other thing, if we're going to be using a proportion test, particularly the two-prop test, we're going to want to make sure that we have at least 5 successes and 5 failures in each group in each for each proportion. So 5, 5, 5, and 5 we need to check. Well, first one we have 7 out of 24. There's 5 successes, 5 failures. Not by much, but in the other one here we have 2 out of 24. And that 2 is going to be a problem. So we do not meet the 5 success, 5 fail condition for the test, two-prop z-test. But that's okay. In part D, it says that using an advanced statistical method for small samples, which means they use something a little bit different than the two-prop z-test, they were able to get a p-value of 0.0683. So regardless of this issue, they got a p-value. And what we're going to look with this p-value is interpreting it in everyday language. What it means is that this is the probability of finding a difference between these two values as large or larger than the one that we actually saw. So we saw a fairly large difference between these two proportions. There's a just under 7% chance, 6.8% chance, that we would see a difference that large if the null hypothesis were true. If we assume that these two proportions were in fact actually equal, there would only be a 6% chance of seeing the results that we did. So that's fairly decent evidence, but it's not quite 0.05, which is that standard point that we use for rejecting. So in this case, we would not reject the null hypothesis. We don't have evidence from this study to say that cell phones are more dangerous or more distracting. But what we do have is the ability to say that maybe a slightly larger study or a slightly less picky alpha value, let's say 0.1, could prove that cell phones are in fact more distracting than just having a passenger.